Okay, welcome to part 2 on looking at shortcuts to proving triangles are congruent. Alright, so in part 1 we looked at two specific shortcuts. One is side, 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 and the other one is side, angle, side. Okay, side, side, side is when you have two triangles, and these are terrible triangles, but you get the idea. When you have all three pairs of sides are congruent, or they can be shown to be congruent, then that means that the triangles are congruent. Okay, the second kind is side angle side. Let me give you an example of that. Let's say we have something like this, so we know that these are congruent and these are congruent. Well, we also know that vertical angles are congruent. So this would be an example of side angle side. Remember that the angle must be included between the two sides that are congruent. So it has to be in between. Okay? All right, so now we're going to look at two more examples, specifically one called angle side angle and the other one called angle angle side. So before we move on to learning what those are, we need a definition. And last time we had an included angle. Now we're going to have to talk about an included side. It's a very similar concept, but things are switched around a little bit. Okay? So, definition: in a triangle, it is a side in between two given angles. So let's say we have a triangle, and we're talking about two given angles. Maybe this one at the top and this one to the left. Okay? The included side would be the one that's sort of in between the two angles. It kind of connects the two angles. All right, let's look at sort of the same situation, but let's look at a non-included side, which would be the opposite. So we'll use the same two angles. Our non-included side would be either this one or this one. So these are called non-included sides, which is a term that we're going to use a lot. So non-included sides. Okay, so our two next shortcuts are angle side angle and angle angle side. And you may notice that they have the same combination of letters, but the only difference is where the S is. The S here is in the middle. The S here is at the end, and that's on purpose. And that really depends on, is the side included or is the side not included? Okay, so let's take a look at this one. Angle side angle. So angle side angle says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. So let's look at this. Here we have triangle ABC. Our two angles are A and C are congruent to D and F. And you can see that the side that's congruent is connecting them. So AC and DF. That is an included pair of sides that are congruent. And that's important for it to be angle side angle. So if that is true, then the triangles are congruent by angle side angle. All right. So let's do angle angle side. In this case, you have two angles that are congruent. So we have our angles, say A and B, D and E. So two pairs of angles again. But this time you have a non-included side. So there's two different non-included sides we can choose, but in this case AC is a non-included side. See how it doesn't connect between A and B? And then the other one is DF. Okay, they need to be the same sort of corresponding non-included side. Okay, So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side, then, oops, let me erase all this. Come on, erase. Here we go. Then the triangles are congruent. Okay, so in conclusion, we've got four: side, 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 angle, side, angle, side, angle, and angle, angle, side. These are the four shortcuts that we need to know. There are two that I want to talk about that don't work. One of them we already talked about is side, side, angle. This one does not work. Another one that doesn't work is angle, angle, angle. You need to have at least some sides for it to work. So this one does not work either. Okay? All right.